Hi, in this video I will be trying to solve an example of resistors in combination where there will be series, parallel, series again, parallel again. It depends on the situation, but in this example there will be numbers involved, so we need to calculate and determine certain values as the question requesting. So I have 6 resistors connected in this circuit. Now the question asking me to find the R equivalent of the circuit, or the total resistance of the circuit. So to do that, we have to follow the procedure. As I said in my previous video, normally we will go to the opposite side of the battery. So if I want to start, I will go to this region here and start doing the required identification if it's a series or parallel connection with the resistors. So when I look at what I have here, I will notice that R2, resistor 3 and 4, they are connected one end to one end, which means these 3 resistors connected in series. To find the R equivalent, we have to start shrinking our circuit, as I mentioned that in previous videos. So let's write that down. R2, R3, and resistor 4 are all in series, and I will name them R equivalent 1. Now we know the find R equivalent for a series combination. We just add them up. So 5 plus 3 plus 2, that will give me 10 ohm. Okay. Now the new resistor, or the new equivalent resistor, technically I am having, it's kind of like I took all these out and replaced them with another resistor just right here, and I called it R equivalent 1. Now as you can see, R equivalent 1, it's connected with the resistor number 5 and 2 ends directly, so it is in parallel situation. So R equivalent 1 and resistor number 5 in parallel. All right, I will call the outcome of this combination R equivalent 2. So if I want to find R equivalent 2, I can say, all right, it is R5 times R equivalent 1 over R5 plus R equivalent 1, and I can do the calculation for that. That should give us 5 ohm. Okay, so here we go. I took this combination here of these two resistors, the R equivalent 1 and R5, and replace it with a new resistance, with the resistor, sorry, with the value of 5 ohm, and it will be connected right here with R1 and R6. Now if I want to draw that, I can say, all right, I'm canceling this and replacing a new resistor. It's going to be here, and it is R equivalent 2, we called it. All right, so now I have R1 connected end to end with R equivalent 2, connected end to end with R6. They are in series. So R1, sorry, R1 and resistor equivalent 2 and resistor number 6 in series. So that will bring us to the end of the whole circuit, or the total resistor in the circuit, which is just adding these 3 resistors, R1 plus R equivalent 2 and plus the resistor number 6. If you add them up, that will give us 10 plus 5 plus 5 again, it will be 20 ohm. the total resistance of this circuit. Okay, so that's first of all. All right, so now I managed, or I succeeded to shrink this circuit and make it a very simple circuit where I have my battery and one resistor. That's the battery where I have 60 volt and I have my R equivalent, okay, with the value of 20 ohm. Now, the next item in this question asking me to calculate the current and the voltage through each resistor. That's quite a mission, but again, these videos is just to help you practicing deeply and in details every single step. But as a start, we must find how much is the total current in the circuit. So it will be V over R equivalent, and that will give us, it is 60 divided by 20, and it will be 3 ampere. So I know now how much is the total current going through the whole circuit. Okay? Now, to find the voltage across every single resistor and the current through each resistor, we need to reverse the process, the shrinking process of our circuit, and start expanding. So we're going to start where we ended. We're going to start from here, and we're going to reverse the process one step back, where it will be R1, R equivalent to, and R6. So technically we are reversing to go back to here. All right, so let's draw this, and it will be like this. I will have and that's my battery. So this is R1, this is R equivalent 2, and I have here R6. Okay, now here we go. We're going to use what we learned about series and parallel resistors. Now I can see they are connected in series, which means they will have the same current. So here we go. I total will be the same current through R1, the same current going through R equivalent 2, and the same current going through resistor 6. They all will be 3 ampere. So I managed to find the current for 3 elements in this whole circuit. Now to find the voltage, that's a different thing. We remember they will share the voltage. They will share that 60 volt between them. So let's find this out. Now the voltage for 1, it will be the current times R1. Okay, that will give us 3 times 10, it is 30 volt. Now voltage equivalent to will be I R equivalent to, again 3 times 5, that will be 15 volt. Now the voltage cross 6 or R6, it is I6, that will be 3 divided by 5, again 15 volt. All right, now let's check. If you go and check the total of these 3 voltages, 30 plus 15 plus 15, bring me back my 60 volt voltage across the battery. That's good. The other thing, is it really still the bigger the resistance, the more voltage will take? Yes, because R1 definitely is the biggest between these 3 resistors. It was 10 ohm, so it will take the most of that 60 volt. Okay, now step back, we're gonna share, we're gonna still doing what we're doing. Now this resistor here, the equivalent to, we need to move it one step back. So if I go back, you will find that R equivalent to, it was the combination of R equivalent 1 and R5, the resistor number 5. Okay, and they were parallel. Okay, So here we go. I will take this part and move here. It will be, it's a combination of, sorry, it's a combination of R equivalent 1 and resistor number 5. Okay? That's what was R equivalent to. Now, we need to use, again, what we learned about resistors and their connections. They are connected in parallel, which means whatever was the voltage across R equivalent to will be the same voltage across these two resistors. So the voltage across equivalent to is the same voltage across 5 and the same voltage for equivalent 1, and it is 15 volt. Great. I can use that to find now the current. So the current through 5 will be V over the resistor 5. Just following the numbers, it will be 1.5 volt, and current through equivalent 1, it is the voltage of equivalent 1 is still 5, and still 15, and R equivalent 1, we have to go back, and it's by coincidence it's 10 as well. These two values, 1.5 volt. Okay, sorry, my bad. Let's pull this back out. I'm trying to find the current, not the voltage. Sorry, I can retrieve that easily. So here is ampere and here is ampere. Now you can see that the total current going through these two resistors is 3 ampere, which was the same current was going through resistor equivalent to, also 3 ampere. So we are doing fine and everything accurate. Now what we need to do in our steps, this last item, the R equivalent 1, need to be expanded. And when I expand it, it will take me back to the first step where I have R2, 3, 4 in series. Okay, so let's take it. So it will be like this. It was R2, R3, and R4. That was the R equivalent 1. So now I know how much the current was going through R equivalent 1. The current going through R equivalent 1 will be the same current going through 2, the same current going through 3, the same current going through 4, because they are all connected in series. It will be 1.5 ampere. Now I can find the voltage these three resistors will be sharing, all right, and it depends on their values. So if I'm gonna find the voltage 2, it will be I going through to R2. Let's write it down quickly, and that will be 3 R3, and finally the voltage across 4. You just need to do the calculation with, as we started with, you will have this one 7.5 volt, and for the resistor number 3 I will have 4.5 volt, and for the last one I will have 3 volt. Once again, if you add up, you will end with 15 voltage across what was on R equivalent 1, because it was coming from R equivalent 2. I hope this example enough with good details to make you practice in deep every single item. We'll see you again with another example similar to this one. Thank you.